Video will break down the difference between classful and classless addressing. And before we get into the specifics technically here, let's take a little trip back in time. So back when I used to have a computer that looked something like this, with one of these big monitors, I got my first high-speed internet connection. It was actually an ADSL connection. And many of my friends had cable modems. It was when all this stuff was just starting. And I actually used to have a public IP address associated with my computer. So my computer could browse the internet, and it actually had a public IP address. Back in the late 90s, they were giving out public IP addresses for every single device that was connected to the internet. The problem with that approach is there's only so many public IP addresses. And these public IP addresses are broken down into class A, B, and C. So let's start by looking at a class A IP address range and understand what that means. So the only possible IP addresses start with 0.0.0.0, right? We have 4 octets, and the largest any number can be within one of those octets is 255. I'll explain why that is later on when we break down binary and how we can convert these IP addresses to binary format. But let's just start by understanding that every single octet can possibly be between the value of 0, each of these octets, and 255. That's the lowest and highest possible value of any octet. And so with that being said, there's a limited number of IP addresses that we can possibly come up with. And so when the internet was young, they figured, hey, we have to control these addresses. But they weren't really careful about who they gave them out to. We weren't expecting the internet to get as big as it did. And so they identified the 1.0.0.0 through 127.0.0.0.0 address ranges as class A. These are class A address ranges. And what a class A address range essentially means is that they are going to give out these addresses as a whole. So let's say, for example, one organization requires IP addresses. They would give one organization 1.0.0.0.0. And maybe another organization would get 2.0.0.0. And another organization would get 3.0.0.0. And on the list goes. Here's the problem. These class A addresses are absolutely massive. And so if some organization were to get one of these class A address ranges, they could have over 16 million devices that can get an address within that class A address range. And so if we start giving out class A addresses to organizations, they are going to get an absolute massive amount of IP addresses. So they said, well, we don't want to necessarily give out that many addresses to everybody. Let's create 2 more classes of IP addresses, Class B and Class C. And so with a Class B IP address range, this can be any address from 128.0.0.0 to 191.255.0.0. So if you have a public IP that falls between these addresses, that's a Class B address range. And these address ranges are smaller. They're only going to give out 65,534 possible devices. So although they're still really big, 65,000 devices is a lot of devices, they're still a lot smaller than a Class A IP address range. But most organizations aren't going to have 65,000 plus devices. So they came up with a third range of addresses, the Class C address ranges. And these are the smallest of the three. Class C addresses are going to fall between 192.0.0.0 and 223.255.255.0. And each one of these address ranges, if you get a Class C for your organization, you can support a maximum of 254 devices. And so for years, this worked. For years, this was fine. The problem becomes, hey, what if I'm an organization that needs, I don't know, let's say 2,000 devices? Well, maybe they'll give me a Class B, because that's the address range that could support 2,000 devices. Well, in that case, I'm wasting 63,000 addresses. Well, we could also give me multiple Class C address ranges, and I could just kind of bunch them all together. But it's not the most flexible system here. And because there's so many more devices on the internet now than there used to be, it would be ideal if they could allocate just the smallest possible range of IP addresses to an organization. So if we get a little bit more flexibility, that would be very helpful here. Like, wouldn't it be great if we had an organization that required 1,000 IP addresses and we could give them an address range that included 1,024 IP addresses? Well, then I'm really giving them 24 more than they need. And so although this class system of IP addresses still exists, we've greatly changed the way that things work by using something called variable length subnet masking, which we are going to learn much more about later on. But basically the idea here, and you can kind of think of this classful boundary as with a Class A, the first octet is the network address. That's kind of where you draw the line, right? So if you're getting a Class A address range, the first octet is the network, and you can play with all of the space in the next 3 octets. So 3 octets worth comes out to about 16,777,000 devices. The Class B, the first 2 octets refer to your network address, and the last 2 octets, those are usable by you. You can customize them however you want. So for example, your organization might get the 128.14 network. So every device in your network that has a public IP has to start with 128.14, but then you can use these last 2 octets however you want. And so that's going to give you about 65,000 devices. Then a Class C, the first 3 octets are the network portion of the address, and you have one little octet here to play with. So for example, let's say that you were to get the 195.128.1 network. Well, the first 3 octets you could not change. It would be 195.128.1. The 4th octet, that's yours to do with as you please. But really the most important thing for you to recognize right now is to understand the inflexibility of this model. By forcing these addresses into these classful designations, we can't just give out the right amount of addresses for the right job. We have these very rigid rules about how many addresses can be given out. If we give out a Class A, we're giving out 16 million plus addresses. Class B, 65,000 plus, or Class C, 254. And there's a huge difference between those address ranges. As time went on and the internet got more devices, we came up with things like network address translation and variable length subnet masking to alleviate and prevent the exhaustion of public IP addresses. And that's why IP version 4 is still part of our lives. I remember in college back in the late 90s, they told me that IP version 4 was going to be gone in a few years, that we were going to have to go to IP version 6. Well, that's because things were different back then, and they came up with many ways to save this public IP version 4 address space. and we'll learn much more about that as we get deeper into this course.